Good morning, students. Since this is my first class, let me introduce myself. I am Vijayanand, lecturer in the Department of Botany. In this semester, I will be dealing with Unit 7, that is Gymnosperms. Under this unit Gymnosperm, you will be studying first about the general characteristics, of the gymnosperms. Next, the classification of gymnosperms. Classification is after family. Only after family we will study. After family level. Then followed by type study. That is one about cycas and the other one finds. Actually, in your CBCS syllabus, you will be studying only about this cycas and finds. Only two type studies are there. Under this, you will be studying about the morphology, anatomy, and reproduction in case of both these cycas and finds. Actually, in the older syllabus, even you had another gymnosperm, that is Nidam. You had this type study of Nidam also, but in your syllabus it is not there. Only you will be studying about cycas and finds. So this is the brief introduction of the syllabus about the gymnosperms which you will be studying in this semester. So let me first explain you the definition of the term gymnosperms. Actually, the term gymnosperm, it is derived from the Greek language. In Greek, as I have said, the gymnosperms is derived from the Greek language. If you split the word gymnosperms, it splits into two words, that is gymnos and sperma. Gymnos means naked and the sperma means seed. So these gymnosperms, they are commonly known as naked seeded plants. So what do you mean by this naked seed? Usually what happens in case of higher plants, particularly in case of gymnosperms, immediately after fertilization, the zygote will be formed. After fertilization, during reproduction, what happens? The male gamete fuses with the female gamete during fertilization. So they both produce a diploid zygote. So this zygote, what happens? It undergoes continuous division and it forms an embryo. That embryo later develops into seed. And in case of gymnosperms, what happens? In case of angiosperms, what happens? Around the seed, if you consider this as a seed, around the seed, ovary wall will be developed or fruit will be developed like this. Around the seed, fruit will be developed in case of angiosperms. But in case of gymnosperms, what happens? Around the seed, this fruit wall will not be developed. The seed will remain exposed to the air, or it remains as naked seed. There is no formation of fruit around the seed. The seed remains naked. Because of this reason, the gymnosperms, they are known as naked seeded plants. So the term gymnosperms was first used by one of the famous botanists, Theophrastus. Theophrastus was the first botanist to use the term gymnosperms for naked seeded plants. He used this term in 300 BC. This Theophrastus is regarded as the father of botany. So this is about the basic definition of gymnosperms. If you look at the plant kingdom, they are subdivided into the plants. They are subdivided into 6 groups: algae, fungi, bryophytes, pteridophytes, gymnosperms, and angiosperms. In your previous classes, that too, particularly in your pre-university classes under plant kingdom chapter, you have studied in brief about all these groups of plants. From algae to pteridophytes, they are regarded as cryptogams. Or they are also regarded as aspermatophytes. Why they are regarded as aspermatophytes means they do not produce seeds. Actually, if you split the term spermatophyta, sperma means seed and the phyta means plant. So this group of plants, they do not produce seeds. So they are divided under the group aspermatophyte. But both gymnosperms and angiosperms, they are regarded as spermatophytes. Since both these angiosperms and the gymnospermic plants, they produce seeds, they are divided under spermatophytes. So, as I said earlier, in case of both angiosperms and gymnosperms, seeds are produced, but in case of angiosperm, fruit will be developed or seed will be enclosed inside the fruit, but the fruit is not found in case of gymnosperms. The seed is exposed. Actually, these gymnosperms, they have actually originated in Paleozoic era. That is, these gymnosperms, they have started arriving or they have started originating on the earth in this Paleozoic era. That took 250 to 500 million years back, the gymnosperms started originating on the earth, and they were dominant in the Mesozoic era. In this Mesozoic era, they were dominant. That means on the earth, these gymnosperms are dominated. The Mesozoic era was dominated by gymnosperms. Because of that, this era is also known as the era of gymnosperms. Since the gymnosperms are dominant in Mesozoic era, this era is also known as era of gymnosperms. And in this Mesozoic era, even the Jurassic era will come. During the Jurassic era, all the forms of dinosaurs were exist. So, during those periods only, the gymnosperms were dominant. So, this is about the origin of gymnosperms. Actually, they have originated. They started originating on the Earth in Paleozoic era. That is around 350 to 500 million years back. But they were dominant on the Earth's surface in Mesozoic era. Next, coming to the general characteristics of gymnosperms. Under general characters, first let us see the occurrence and distribution of gymnosperms. Usually these gymnosperms, they are mainly present in both tropical and temperate regions. In both tropical and temperate regions. In tropical regions, they are present in both the northern hemisphere and in southern hemisphere. In this northern hemisphere and southern hemisphere, what happens? These regions, they are commonly known as cold climatic regions. Usually, the climate will be colder in this northern and southern hemisphere. And in these temperate regions, they are present in arid regions as well as in desert regions. And the tropical forests, they are present particularly in northern and southern hemisphere where the climate is colder, and in temperate regions particularly they are present in arid and desert regions. In both of these regions the temperature will be very high, and even in arid and desert regions it will be having water scarcity. So we can say that these gymnosperms, they mainly present in the regions where you have harshy climate. Either it will be colder climate or it will be hot climate. Some of the examples of gymnosperms where they grow in colder climate regions. Most of the conifers, they are present in northern and southern hemisphere. Some of the example being Pinus, Taxus, Araucaria, so these are some of the gymnosperm species. They are mainly present in northern and southern hemisphere. That too, they are present in the cold mountain regions. In the cold mountain regions, these conifers are present. So the best examples for these conifers is the Pinus, Taxus and Araucaria. All these are present in cold mountain regions. And there is a species of gymnosperm known as Welwitschia. There is a species of gymnosperms known as Welwitschia. It is mainly present in desert region. In desert region, there is a scarcity of water. So this Welwitschia is the best example of gymnosperm where it is present in desert. Welwitschia. Next, there is one more species known as ephedra. It is usually present in arid regions. In arid regions also the temperature will be high and there is scarcity of water. So these are some of the examples of gymnosperms which are present in arid and desert regions. So this is about the occurrence and distribution of gymnosperms. And one more thing, in India we have about 20 genera of gymnosperms. In the world, on the earth, totally we have about 70 genera of gymnosperms, total 70 genera, and around 900 to 1000 species. Total 70 genera of gymnosperms are reported till today, and around 900 to 1000 species are reported. Among these, in India, we have found only 20 genera. That too, around among those 20 genera, we have only 14 genera which are native to India. 14 are native to India, and the remaining they are exotic in nature. Some of the examples of gymnosperms which are commonly present in India are Pinus, Citrus, Podocarpus, Taxus, and there is one species of gymnosperms known as Natum. This Natum, it is usually present in tropical rainforests. This Natum species, it is present in tropical rainforest. Even in our Western Ghats, this Natum is commonly seen in our Western Ghats also. So this is about the occurrence and distribution of gymnosperms, both in the northern and southern hemisphere, both in tropical and temperate regions, even in India. So next, coming to the habit and habitat of the gymnosperms. So if you look at the gymnosperms, most of the gymnosperms, they are evergreen in nature. Evergreen means they do not shed their leaves, as in case of deciduous. All along the 12 months duration in a year, they are evergreen, and most of them are woody in nature. Most of the gymnosperms, around more than 75% of them, they are woody in nature. Only some are climbers, like Nita, wherein you will find the plant body is climbing on the support. Other than that, all other forms of these gymnosperms, they are tree forms and they are woody in nature. So this is about the general introduction, particularly about the occurrence and distribution, then habit and habitat of the gymnosperms. Next, we will move on to the external morphology of gymnosperms. If you look at the external morphology of gymnosperms, the plant body is sporophytic in nature. The plant body is a sporophytic in nature, and it is well differentiated into root, stem, and leaves. The plant body is differentiated into root, stem, and leaves. If you look at the lower group of plants, particularly the cryptogams like algae, bryophytes, pteridophytes, and fungi, the plant body is known as a thallus. The plant is not differentiated into root, stem, and leaves. Instead of that, the plant body is flat, so it is known as a thalloid plant body. But in case of gymnosperms, the plant body is well differentiated into roots, stems, and leaves. If you look at the roots, the root system in case of gymnosperms, it is a tap root system. So usually in plants you will find two types of roots. One is taproot system and the fibrous root system. But in case of gymnosperms, commonly you will find taproot system. In taproot system, what happens usually during germination, the radicle will comes out, and this radicle will act as a primary root, or it's also known as main root. This radicle, when it comes out of the seed, it develops into a primary root, and from this primary root, secondary and tertiary roots will arise. From the main root, secondary and tertiary root will be arising. So this kind of root system is known as taproot system, and in case of gymnosperms, you will find taproot system. And another important feature in case of root system, particularly in some of the species like cycas and pinus. In case of cycas and pinus, the root system show symbiotic association with algae and fungi. In case of cycas, there are special types of roots are found, which are known as coralloid roots. These coralloid roots, they show symbiotic association with algae. What do you mean by this symbiotic association? In case of symbiotic association, both the organisms, they are present together or they are living together, and both of them are getting benefited. Both of them are getting benefited. So that kind of association is known as symbiotic association. And in case of cycas, the roots of cycas show symbiotic association with algae. That too particularly nitrogen fixing algae like nostoc and anabena. These nostoc and anabena, they are present in the roots, the particularly coralloid roots. They show symbiotic association. These roots of cycas, they provide a home for this nostoc and anabena. So in turn, this nostoc and anabena, they help in fixing the nitrogen, and the nitrogen is getting transported to the other plants, other parts of the plant from the roots. So both of them are getting benefited. And in case of pinus, the roots of pinus, they show symbiotic association with some of the fungi. So that is known as mycorrhizal association. Some of the fungi, they are present in the roots of pinus. So what these fungi does is, they help in providing they help in absorbing some of the nutrients, and all those absorbed nutrients, they are getting transported from roots to the other parts of this pinus. So in this way, this fungi is helping for pinus. So in turn, what this pinus roots does is, they provide home for they act as host for this fungi. So both of them are getting benefit. So this is one of the important feature in case of gymnosperms, particularly in case of cycas and pinus. Cycas show symbiotic association with algae, particularly roots, and the pinus roots show symbiotic association with fungi. So in the next class, we will discuss about the stem, the morphology of stem and the morphology of leaves.